Okay, for today's topic, derivative of a function using
Power. Baskal na naman, basic calculus, basic ka mo bagsak.
Struggling with basic calculus? Keep watching.
But before we begin, let's take a look at our objectives. By the end of this video, you should be able to understand derivatives using power rule, solve derivatives using the formula, apply it in real-life situations, and number 4, solve derivatives using power rule involving constants, fractions, and negative exponents. Now, what is a derivative?
A derivative is a measure of how a function changes with respect to a variable. In simple terms, it tells us the rate of change or the slope of a function at a specific point. Now that we know the meaning of derivative, let's define what is a function. A function is a mathematical relationship where each input, x, has exactly one output, y. For example, f of x equals x squared. Now, let's proceed to the important terms that for sure we will encounter. Here, we have 4 important terms to consider. 1. Exponent. An exponent is the small number written above and to the right of a variable. It tells how many times the base is multiplied by itself. For example, in x cubed, the exponent is 3. Next, coefficient. A coefficient is the number in front of a variable and it multiplies the variable. For example, in 5x raised to 2, the coefficient is 5. Then, constant. A constant is a fixed number that does not have a variable. Its value does not change. For example, is 7, -3, and 10. Last but not the least, power rule. The power rule is a formula used to find the derivative of a function in the form of x raised to n.
The formula of the power rule is just simple. F prime of x equals to n, x raised to n minus 1. But now, I'll explain the parts of this formula. First is the f prime of x. It is called the derivative. It tells us how function changes. Then n, it is the coefficient, and x is the variable in a function. Then lastly is the n minus 1. It means subtract 1 from the exponent after bringing it down. But what does it actually mean? It means when you see raised to a power, you only need to follow 2 steps. First, bring the exponent down in front. Then second is subtract 1 from the exponent. And just like that, finding derivatives becomes much easier.
Today, I will show an example on finding basic derivative using power rule. Let's consider the function f of x equals x raised to 4. First, let's identify which one is the exponent. After that, we're going to put the exponent in front of x. Then, since the exponent is 4, let's subtract it by 1. Then it will give us 4x raised to 3. Then the derivative of f of x equals x raised to 4 is f of x equals 4x raised to 3. The power rule states that if f of x equals x raised to 4, then the derivative of it was f prime x equals nx raised to n minus 1. This means we multiply the functions by the exponent and then subtract 1 from the exponent. In conclusion, using the power rule make it easy for us to find the derivatives. We only need to bring down the exponent and reduce its power by 1.
Let's now proceed with multiplying. Let's take a look at this example. Let's first identify the parts. 7 is the coefficient and 3 is the exponent. Now, multiply 7 and 3. 7 times 3 is 21. Then subtract 1 from the exponent. So 3 minus 1 is 2. And our final answer is 21x squared. And then another example, 3x raised to 5. So multiply 3 and 5. 3 times 5 is 15. Now subtract 1 from the exponent. 5 minus 1 is 4. And then our final answer is 15x raised to 4.
So now, let's talk about negative exponent in derivatives. When we find the derivative, we use the power rule. And the power rule says, we multiply by the exponent and then subtract 1 from the exponent. So now, here are example and let's apply. So our example is f of x is equals to x raised to negative 1. So first, multiply by the exponent. So negative 1 times x raised to negative 1 is equals to 1x raised to negative 1. Then, we will subtract it by 1. Now, negative 1 minus negative 1 is equal to negative 1. So now, the answer becomes f of x is equal to negative 1x raised to negative 2.
Do you know this rule works even if the exponent is a fraction? Let's find out how.
Let us look at the example here, which is the f of x equals x raised to 1/2. First, we are going to multiply the exponent by the expression and subtract 1 from the exponent so that we can get this answer, which is the f prime of x equals 1/2 x raised to negative 1/2. Since the exponent is negative, we will make it positive by placing it to the denominator. And the answer is f prime of x equals 1 over 2x raised to 1/2 or 1 over 2 the square root of x, since the x raised to 1/2 is equivalent to the square root of x.
Go.
In summary, when solving derivatives with fractional exponents, we simply apply power rule and write negative exponents as positive ones by moving it to the denominator. Now, let's talk about constants. A constant is a number that does not change. It is not attached to a variable. For example, 3, 7, negative 5, and 10. They are all constant. When we take the derivative of a constant, the answer is always 0. Why? Because derivative measures how a function changes, and constant does not change at all. For example, we have here f of x is equals to 7. The derivative of it is f of x is equals to 0. So, whenever you see a constant function, the derivative of it is always 0.
To test your attentiveness and if you are actually able to learn from our lesson for today, we'll do a quick quiz on derivatives using the power rule. For the answers, number 1, 5x raised to 4 plus 2, 21x squared plus 3, 10x raised to 9 plus. For number 4, 28x raised to 6 plus 6x. Number 5, 36x cubed minus 5x. Did you get all the answers right? You all did well. Remember, the power rule is your best friend for derivatives. Keep practicing and you'll get even faster at it.
And that brings us to the end of our presentation. We hope that through these examples and explanations, you were able to better understand how exponent works and how they can be applied in solving mathematical problems. Thank you for listening and participating. We hope you learned something new and useful today. Have a great day, everyone!